Hello, this is the third video in the series about evidence-informed ideas that all teachers should know. And here we're going to talk about the concept of schemas, the idea that knowledge in our long-term memories, in our brains, forms in a network of concepts and ideas which form a schema. And this is how we remember things. So for example, if I was to suddenly zap you somewhere, let's say New York. Now you weren't thinking about New York until a second ago, probably, but now we're in New York. We find that we have a schema for New York, and we can explore it. We can go into our memory and explore our schema for New York, and we think about it in terms of its geography, some film associations, and even if you've been there, you'll have memories of things that you did there, the roads, the smells, the place you went for lunch. But you weren't thinking about that before. So when we have a schema for an idea and we then try to remember it, a lot of that knowledge can come to our short-term memory altogether. But significantly, it doesn't arrive there altogether. We have to actually build our schema slowly over time. And really importantly, when you're teaching a concept to a class of individuals, everybody's schema is different, sometimes significantly different. So when we're trying to teach new knowledge to children, we've got to be thinking, how does this fit to their existing schema? So new knowledge builds on existing knowledge, and the more sophisticated your prior knowledge is, the more elaborate your schema, the more easy it is for you to assimilate new information and to make it stick, because you've got more different ways to connect the information. So the more you know, the more you can know, and you can't know too much. So building knowledge is really, really important as a notion for what teachers are trying to do. I think it has implications for what we then need to do as teachers in terms of being responsive in our questioning. Because if we're just thinking about giving information to students, hoping that they'll be forming the schema, we could be wrong. We could actually be failing for that knowledge to stick at all because their foundations were too weak. Or, importantly, they could be actually connecting things in an incorrect way because their prior knowledge was slightly lacking and their schemas could be filled with misconceptions. So we need to be aware of that and always be thinking, right, how has this knowledge been assimilated by all of my students? And in order to do that, I need to get a lot more information back to me as the teacher from my students about what they've understood. So I can check whether they've understood and whether the schema that they're forming around this idea has taken shape. That implies lots more questioning, lots more interactive, probing questioning. And it also means that when one student's answer can never represent the learning of others because we don't know how their prior knowledge, their schema, will have formed. The other major thing is that we need to anticipate common misconceptions, and there are lots of them. There are lots of them in science, there are lots of them in maths, there are lots of them about history. And if we know the kind of common things that often form a poor schema, we can anticipate those. Because here's another thing about schemas. If you just try to overwrite a primitive schema with a more sophisticated one, unless that old schema never really disappears, it doesn't evaporate, it's still there. Unless the new knowledge was very strong and kind of masks the old one, students can revert back to their primitive schema quite easily. So even if I, for example, tell you that the mass of a tree mainly comes from the air, because carbon dioxide is absorbed through trees' leaves, and that's the heavier molecule in photosynthesis. The intuition a lot of children have is that most of the mass of a tree comes from the soil, because that's more intuitive, and the schema for how trees grow is that they come out of the ground. So to overlearn that, to kind of correct that schema of the material for a tree coming mainly from the air, requires you to address the misconception head on and actually break that down and explain and deal with that misconception directly. That's more likely to be effective than just hoping that the new idea will overshadow the old one, because the likelihood is that it won't. So there we go. Thinking about this idea of schemas, the differences between individuals, and the conscious and conspicuous need to build schemas that are correct and provide solid foundations for future learning, I think is really powerful, really instructive. And once you think that way as a teacher, I think you're going to make better decisions when you come to asking questions and setting tasks.